If we look at the specific rate calculation between, let's say, this point and this point, the 81 seconds at 30 centimeters, 100 seconds at 20 centimeters, we see that there's a 19 centimeter or 19 second difference and a negative 10 centimeter difference, of course, giving us an average rate of negative 0.53 centimeters per second. If we look at the graph, at the corresponding points on the graph, we see that we have the point 81 seconds, 30 centimeters, 100 seconds, 20 centimeters, more or less lined up along those coordinates. We see that the delta t is represented, the change in the clock time is represented by the distance from 81 seconds to 100. We take that and we start at the data point and move to the right for that 19-second distance, and we call that the run of a triangle between the two data points. Then we have a rise of negative 10 centimeters, of course corresponding to the change in depth from 30 to 20 centimeters. The average rate is the change in depth divided by the change in time, and of course that's nothing but the slope. The slope of this is the rise over the run. The rise is your negative 10 centimeters on top here. The run is your 19 seconds on the bottom. So what we see is that the average rate is represented by the slope between these 2 points, the slope of this line segment, and that's negative 0.53 centimeters per second, consistent with the negative 0.53 centimeters per second that we calculated when looking at the table.